Hello, Sioux High Earth Science students. This is Mr. McLeod again. Welcome to our next astronomy podcast. Today we'll be reviewing the Big Bang Theory and the idea of an expanding universe, as well as exploring how stars like our sun are formed. So have your notebook handy and a pen or pencil, and let's do this thing. As always, there will be some questions for you in Moodle at the end of this podcast, so make sure you get those done and submitted as soon as possible. Also remember, you can pause or rewind this podcast at any time if you miss something. Okay, we've talked about the Big Bang several times in our class, but let's go over the basic concepts of this theory and expand on them a little bit. The Big Bang marks the beginning of the universe, and the latest evidence indicates it occurred between 13 and 15 billion years ago. We've often used the number 13.7 billion years in our class, which certainly fits this time frame. Now let's take some notes. The basic idea behind the Big Bang is that all matter in space was created at the same time, about 13.7 billion years ago, from a single point called a singularity. Write that down in your notes. Also write that contrary to the name, this was not a huge explosion that hurled matter in all directions, like the typical explosion of, say, a bomb we've all seen in pictures and movies. What we mean is that technically there was no bang. In fact, during the Big Bang, matter's not even moving outward in all directions. It's the space around it that's moving. So write that down. Okay, that might sound a bit strange, right? Space. You know, space. The black stuff between stars and planets. Yes, it's actually that is moving and expanding. Put that in your notes. Now, because the space is expanding, all the stuff space has in it will automatically expand with it. Write that down. Kind of a difficult concept, right? Well, let's remember our raisin bread example. Okay, so let's review our raisin bread example. So when we bake the bread, the dough expands. Therefore, the raisins in the dough also expand because of this movement. If you need to write that in your notes, write it. Now let's apply this to galaxies. The raisins in the bread represent galaxies, and the dough between them represents space. So just as the raisins move with the expansion of the dough, galaxies would also move with the expansion of space. Make sense? Find a way to write this explanation in your notes right now, and even draw the above diagram if you think it'll be helpful. Okay, let's look at some evidence for the expanding universe that we have right now. First, some background information. Again, let's get this in your notes. First, stars are made of gases that emit specific wavelengths of light based on their chemical composition. Stars are made of gases that emit specific wavelengths of light based on their chemical composition. Get that down in your notes. Next, Each of those gases emits certain wavelengths that are unique to that element. Again, get this down in your notes. Okay. The combination of a star's gases can be used to identify the star like a fingerprint or barcode. Write that down. So the combination of a star's gases can be used to identify the star like a fingerprint or barcode. We call this a line spectrum. So we call it a line spectrum. And in this slide, you see several kinds of examples of line spectrums. Again, get this down in your notes. Now, the spectral lines you see here in this diagram are lines that correspond to various wavelengths of gases seen in an element's spectrum. Okay, now let's tackle the idea of red and blue shift. This is important evidence that supports an expanding universe. So let's look at how it does that. When scientists look at the wavelengths of the spectral lines emitted by stars in faraway galaxies, they notice a couple of important things I'd like you to get in your notes. First, the positions of the wavelengths of stars coming toward the Earth are shifted to the shorter wavelengths or blue light end of the spectrum. Get that down in your notes. The positions of the wavelengths of stars coming toward the Earth are shifted to the shorter wavelengths or blue light end of the spectrum. If you look in this diagram, you can see the blue light end of the spectrum in the bottom right. Okay, second, the position of the wavelengths of stars moving away from the Earth are shifted to the longer wavelengths or red light end of the spectrum. Now write that down. So the position of the wavelengths of stars moving away from the Earth are shifted to the longer wavelengths or red light end of the spectrum. Again, bottom right, take a look at where the red light spectrum is. Okay, next, write this in your notes. The shifting of these wavelengths is referred to as the Doppler effect. So write that down. The shifting of these wavelengths is referred to as the Doppler effect. We experience the same effect with sound waves. Now let me show you an example. So I want you to listen now as this car approaches, then passes in this video. When you are standing listening to a car approaching you, the sound is higher the further away the car is and gets lower and lower pitched as it approaches you. That's called the Doppler effect. So the further away it is, the higher the pitch, the closer it gets, the lower the pitch. And then as it goes by you, pitch gets higher again. In 1929, Edwin Hubble observed that spectral lines emitted by stars in distant galaxies were considerably red-shifted. Write that down. In 1929, Edwin Hubble observed that spectral lines emitted by stars in distant galaxies were considerably red-shifted. Now let's look at what that means. If we look at this diagram, we can make some important conclusions. Let's write them in your notes. First, objects coming closer to an object at rest will be blue shifted. That means they're coming towards the object at rest. Write that down. Secondly, objects moving away from the object at rest will be red shifted, meaning they are moving away from the object at rest. Write that down. All right, let's tie these two conclusions together. When we apply these concepts to Hubble's discovery, meaning that distant galaxies are redshifted, it means they have to be moving away from us. Write that down. Now, this is the best evidence for an expanding universe. The idea that galaxies are moving away from us or expanding. Okay, last and most recently discovered piece of evidence for the Big Bang Theory and the idea of an expanding universe. We now understand that space continues to expand outward from the original Big Bang, and that it's this expansion of space that causes distant galaxies to be moving away from us or redshifting. However, we also need to include energy in this theory. Okay, first thing to write in your notes. Energy created by the Big Bang is also expanding and moving outward along with matter, such as galaxies. So write that down. Energy created by the Big Bang is also expanding and moving outward along with matter, such as galaxies. Okay, next. If this is true, then we should be able to detect that energy all over the universe, mixed in with the energy given off by stars. Write that down. Okay, next, evidence of this long wavelength background radiation called cosmic microwave background radiation has now been discovered and appears to be coming from all directions in the universe. That's a lot, so write this down. Evidence of this long wavelength background radiation called cosmic microwave background radiation has now been discovered and appears to be coming from all directions in the universe. Okay, last thing to write in your notes is that this cosmic microwave background radiation was discovered by Arno Penzias and Robert Wilson. You can see their names on this slide. And they won a Nobel Peace Prize for this discovery. So write that down. What's interesting is that Penzias and Wilson discovered cosmic microwave background by accident. Ask me about the story sometime. It's really strange. All right, now off to Moodle to answer the questions from this podcast. See you later.